This lesson is size transformations, and you may also see this word dilation. So if you think about if you go get your eyes dilated, your pupils get really big. So dilation is just another word for size transformations or resizing. And our learning target is going to be, I can resize figures. So we're going to make them bigger or we're going to make them smaller. Alright, so here's some basic stuff going on. We talked about this previously. This would be our pre-image because if you notice there's no apostrophes on the letters. And then this one would be our image because we do have the apostrophes, so that's our A prime, B prime, C prime. Remember, the pre-image is your original and your image is after the transformation has occurred. Okay, so a size transformation can refer to the enlargement or reduction of a figure. Okay, and then there's something called the scale factor. The scale factor indicates how much the figure will enlarge or reduce. So if it's going to double in size, your scale factor would be 2. If it's going to triple, it would be 3. So we always use a K to represent a scale factor. So anytime you see a K and you're talking about size transformations, you're talking about scale factor. So when the K, the number, whatever the scale factor is greater than 1, that's an enlargement. Means it's going to get larger. And when K is less than 1, the dilation is going to be a reduction. So reduce in size. If K equals 1, that's a trick question. It stays the same size. Because you multiply anything by 1, it stays the same. So these are pretty easy. I like these. If you look back at our geometric rules, when we talk about size transformations, you really just multiply the x and y coordinate by whatever the k value is. So it would look like this. So this is the only time you do multiplication when you're talking about transformations, is when you're resizing something. So it would not be a congruent figure. It wouldn't be the same size anytime you're dealing with multiplication. Alright, so our k value is 1/2. So eventually what we're going to do is multiply the x and y coordinates by 1/2. What I want you to do right now is just to graph the rhombus JKLM. Okay, so because the k value is less than 1, we should expect a reduction. And that's what we're going to do. So we started out that j was -10, 2, and all we're going to do is multiply both those coordinates by 1/2. So -10 times 1/2 is -5. 2 times 1/2 is 1. And then do the same thing. So k was -2, 8. I'm going to multiply both those numbers by 1/2. -2 times 1/2 is -1. 8 times 1/2 is 4. And then L was 6, 2. Multiply it by 1/2. 6 times 1/2 is 3. 2 times 1/2 is 1. And then the last one, -2, -4. Multiply by 1/2. -2 times 1/2 is -1. -4 times 1/2 is -2. So let's graph that and see what it looks like. Alright, so sometimes people expect the dilation to be directly in the middle of the original, but that's not what happens because it's reducing it towards the center. And if you were further from the center, you would actually move over more. So I don't know if you can tell that, but the little blue figure is not directly in the center of the purple one. And that's because you're pulling from the center 0, 0. Alright, let's do another example. Alright, so this time we're going to do a rhombus, but we're going to do the k value of 2. So for this one, we should expect an enlargement. So it should definitely be bigger because the scale factor is bigger than 1. So go ahead and graph it. And obviously, I should have used a different piece of graph paper. So we're going to go way off the charts here, but it's cool. We'll work with it. So since our k value is 2, we're going to do 2 times x, 2 times y. So J is now going to be negative 24. I'm just multiplying both of those coordinates by 2. J would be negative 4, 16. L would be 12, 4. And then M would be negative 4, negative 8. So, way over here. Yeah. I messed that one up big time. But we just know, and we know how to figure out the coordinates, and we know it's going to be bigger. So if I had used the right piece of graph paper, it's going to work out the same. All right, let's look at some different stuff. All right, so graph the image of the parallelogram below using a scale factor of 2. So because we know the scale factor is 2, we know we need to multiply the coordinates by 2. So anytime this happens and they don't actually give you the coordinates, you can graph them. Don't freak out about something like that. So M-N-O-P. Go ahead and write down the coordinates, and that'll make your life easier, I promise. Okay. And then because we know that the scale factor is 2, our rule is going to be 2x, 2y. And all we have to do is multiply these coordinates by 2. So M is going to be negative 2, 6. Just multiply both by 2. N prime is now going to be 2, 8. O prime is going to be negative 4, negative 2. And P prime is going to be negative 8, negative 6. And now I'm going to graph these. And I just caught a mistake because I'm half blind. That is not the coordinates for P. Try that again. So the P is actually 4, negative 2. Okay, which makes this one negative 8, negative 4. Sorry about that. I just can't read. So once again, those should not be like inside of each other because you're stretching it from 0, 0. Alright, so I think these are pretty easy. And I think we're just gonna, well, let's just write the rule and we'll write the other stuff. We're just gonna write the points. I'm not gonna worry about graphing it just to save time. So I know that I'm going to multiply both coordinates by 1/4. Okay, and it would really help if you had the coordinates, like you actually wrote them out. So go ahead and write them out. I'll try to actually count a little bit better this time. We'll see what happens. Okay, so F was negative 2, 8. I'm going to multiply both those coordinates by 1/4. So this will actually become negative 1/2, comma 2. G was 4, 8. I'm going to multiply both of them by 1/4, so it'll become 1, comma 2. H prime was 8, negative 4. It will become 2, comma negative 1. And then I was negative 6, comma negative 4. So I'm going to do negative 3/2. If you hate using fractions, you could say negative 1.5, comma negative 1. And then you could graph that and you'll see that it's really small. Okay, so here's another thing that they love to do. To identify the scale factor. So we're trying to figure out what the K value was. So what I suggest you do each time you try to do this is you write out the coordinate points. So D, E, F. And then write out, what am I doing? Write out the image points as well. And it'll be a little bit easier to figure out the scale factor. Okay, so when you list these out, I think it's really easy to see. So we went from 0 to 6, and then 0 to 2. So what would you have to multiply 6 by to get 2? You would multiply it by 1/3. And then check that E is the same thing. To get 6 to 2, 1/3. And then check the F the same thing. Negative 6 and negative 2, multiply by 1/3. If you multiply negative 3 by 1/3, you get negative 1. Okay, so my scale factor is 1/3. And that makes sense because it's less than 1 and it is a reduction. Alright. So here are some questions that you're gonna see on your next test. And if we do take the EOC this year, not the EOC, the final exam this year, there'll definitely be some like this on the final. Go ahead and graph the rectangle DEFG. Okay, Oh, my G is horrible. Let me try that again. Alright, and then the next thing it wants to know is the perimeter and area. So if you don't remember, perimeter is just adding up all the sides. So you have 3, 2, 3, and 2. So the perimeter is going to be 12. And now we're going to do area. So if you don't remember how to find area of a rectangle, it's base times height. So 2 times 3, 6. Okay. So look at part B. We're going to use the rule xy to 3x, 3y. So 3 is the scale factor. So x equals 3. I want you to go ahead and draw the rectangle D prime, E prime, F prime, G prime. So you're going to take the coordinates and you're going to multiply each one of them by 3. Okay, so a common mistake I see some people do is you forget 3 times 3 is 9. So make sure that you did that and didn't say 3 times 3 was 6 or something like that. But this is what your picture should look like. Okay, so now I want you to do part C. I want you to find the perimeter and the area of the green rectangle, of the image one. So go ahead and try that. Oh my goodness, I wish you guys were in here to keep track of me. So that first perimeter, sorry, 3 plus 2 plus 3 plus 2 is definitely 10. Try that again. And now for the green one. The perimeter is 30. And then for the area, we have 54. So what does the scale factor do to the perimeter and area of a figure? How many times as big is the perimeter? You went from 10 to 30. It's 3 times as big, which was our scale factor. So if you're talking about pre-image and an image, the perimeter is always going to equal k times as big. So if this rectangle had a scale factor of 2, the perimeter would be twice as big. If it had a scale factor of 4, it would be 4 times as big. That's what the scale factor does to perimeter. Now look at area. You went from 6 to 54. That is 9 times as much. So the area is equal to k squared times as big. So remember, k was 3. 3 squared is 9. The area is 9 times as big. So we say the scale factor is k squared times as big for area. And that's a big difference between which one you're talking about, perimeter or area. And that only occurs when your scale factor, you're doing it to the same. Like, your scale factor is 3 for the x and the y. If they give you a different rule and they only had a 3 in front of the x, it might be a little bit different. And I'm going to show you some problems like that, so don't get too worried about it. So, the part that is in green right here is the big part to take away from this lesson. And then also remember, this is the only time that when you do transformations, you wouldn't have a congruent figure. They wouldn't be the same size. Alright, the end. Bye.